An important and useful aspect of the Amberg Tunnel project is the project tree. If you select the top node of the project tree, you can modify the name in the property window below. Underneath the top node is the 3D overview. This is the window that by default appears once you launch the project. I have covered the 3D overview in another video. The structure and construction nodes describe two different views of the same project. The structure is a view of the project as a finished structure. This view of the project contains tube headings and shaft headings with chainage axes. It also contains data for tunnel inspection. This view can also be used to derive heading axes and extra information that will appear on certain reports. The background image of the 3D overview is also managed from the structure view. The construction view of the project is a view of the project during construction. In the construction view of the project, you can create one or more sites. In each site, you can create one or more tube or shaft headings. A tube heading is a tunnel element with a non-vertical axis. Each tube heading will have an axis defined by a horizontal and vertical alignment. Both of these alignments describe the 3D curvature of the tube in space. A shaft heading is similar to a tube heading with the exception that it is vertically defined. By definition, a shaft heading is always defined by one straight element, with identical easting and northing values for the starting and ending points. For every site, a design node is automatically created. Underneath the design node, you will see the construction stages. A construction stage in Amberg Tunnel holds the design information for a work step during tunnel construction. In this demo project, for our demo site, we have 3 construction stages defined. First, we have the excavation construction stage, followed by shotcreting, and then finally inner lining. Each construction stage can be made up of 4 elements: theoretical profiles, theoretical sections, transverse slopes, and block definitions. The theoretical profiles describe the design geometry after completion of the construction stage. In this example, we are in the excavation construction stage, and these profiles describe what the excavation should look like in terms of size and shape. Theoretical sections are formed by joining together theoretical profiles along the heading axis. If 2 theoretical profiles that are different in size and shape should be joined together, Amberg Tunnel will interpolate between both profiles. The transverse slope definition is used for the rotation of the entire theoretical profile around the project site axis. This definition is used to incorporate slope or superelevation into your tunnel design. The block definition, like the transverse slope, is an optional definition used in your tunnel design. Each block consists of a start and end stationing and a description, and is used to facilitate the workflow of certain tasks. For each tube heading, you will see a control points node. This is where the tube's control points are stored and managed. Next, we have for each tube or shaft heading the tasks node. This is where you can define Amberg Navigator measurement tasks for carrying out survey tasks in the tunnel. You will see that the task categories are mirrored according to the construction stages defined earlier. The tasks are organized automatically this way because you will likely have different task sets associated with the various different construction stages. Next, for each tube or shaft heading, you will find a measurement node, which is organized again as per the construction stages. Here you can view survey data collected from Amberg Navigator tablet software in the forms of measured profiles, point clouds, and photographs. And lastly, for each tube or shaft heading, we have a powerful set of analysis that can be carried out. If I open up this excavation analysis, we can see the overbreak and underbreak values at different heading stationings. There is a wide range of reporting and exporting options for each analysis. I will take a look now at the blasting round scan analysis. Here we can see a colorized point cloud which corresponds to the deviation between the scan and the theoretical design. If you click on the 2D map, you can see the corresponding profile on the right hand side. This concludes our overview of the project tree in Amberg Tunnel.